For hundreds of thousands of years, they ruled Europe, thriving in landscapes that would kill us in days, hunting massive beasts with nothing but wooden spears and their raw power. They weren't just another human species, they were absolute freaks of nature, the Neanderthals. So, if these stories help you out, hit subscribe, comment your location and time too. Love seeing the mix. Had someone from Helsinki and someone from Houston on the same video. One's in tomorrow, one's in yesterday, or something like that. You think you're strong? You've got nothing on them. The average Neanderthal could crush your hand without even trying. Their bones were thicker, their muscles denser, their power beyond anything we modern humans could comprehend. And for years, we thought they were just primitive cavemen, hunched over brutes that couldn't match our intelligence or adaptability. But that story was wrong, dead wrong. Recent discoveries have completely shattered everything we thought we knew about these ancient humans. Not only were they physically superior to us in almost every way, but their brains were bigger than ours. They crafted complex tools, controlled fire, created art, and survived extreme conditions that would decimate modern human populations. They weren't just surviving, they were thriving in some of the harshest environments Earth has ever produced. So, what made them such extraordinary physical specimens? And if they were so remarkable, why aren't they still here? Why did they vanish while we flourished? The answers will challenge everything you think you know about human evolution. The story of Neanderthals begins around 400,000 years ago, as a population of ancient humans became isolated in Europe during a massive glacial period. Cut off from other human groups in Africa, these Europeans began to evolve distinct traits that would make them perfectly suited for the brutal conditions of Ice Age Europe. Their bodies became stockier and more powerful, not because they were primitive, but because they were becoming specialized survival machines. When we look at a Neanderthal skeleton, the first thing that jumps out is the sheer robustness of their bones. Their bones were significantly thicker and denser than ours. A Neanderthal femur, that's the thigh bone, could withstand forces that would snap a modern human's leg like a twig. Their arms and legs show massive muscle attachment sites, areas where their powerful muscles connected to the bone. Scientists who study these attachment points can tell that Neanderthals had tremendously powerful biceps, triceps, and forearm muscles. But it's not just that they were stronger, their entire body was built differently. They had barrel-shaped chests that were much wider than ours, especially at the bottom of the rib cage. This expanded torso gave them larger lungs and likely a more efficient cardiovascular system. Critical adaptations for high-energy activities in cold environments. Their pelvises were wider too, creating a lower center of gravity that would have made them incredibly stable and powerful. When you look at a Neanderthal skull, you immediately notice the massive brow ridge above the eyes. This wasn't just for show. That bony projection helped support their larger face and provided extra protection for their eyes. Their noses were significantly larger than ours, with wider nostrils and a more pronounced bridge. This wasn't a random trait. It was a sophisticated adaptation for life in the cold. A larger nose with more internal surface area allowed them to warm and humidify the freezing air before it reached their lungs. This prevented the kind of cold damage that modern humans would suffer in similar conditions without technological help. Their facial structure also featured larger sinuses, which further aided in warming inhaled air. These weren't primitive features, they were advanced adaptations that let Neanderthals thrive in environments that would kill most modern humans. Their jaws were another marvel of evolution. Neanderthals had no chin. Their jaw simply curved back from their teeth without the protruding point we have, but what they lacked in chins, they made up for in jaw strength. Their mandibles were thicker and stronger than ours, capable of generating tremendous bite force. The wear patterns on their teeth tell us they frequently used their mouths as a third hand, holding animal skins or other materials while working on them. Those teeth were different too. Their incisors, the front teeth, were larger and showed distinctive wear patterns unlike anything seen in modern humans. Some researchers believe they regularly used their front teeth to grip and pull animal hides when preparing them for use, something no modern human would be able to do without quickly damaging their teeth. All these anatomical differences add up to one conclusion: Neanderthals were powerhouses, but exactly how strong were they? Scientists have used the muscle attachment sites on Neanderthal bones to estimate their strength compared to modern humans, and the results are staggering. The average Neanderthal likely had upper body strength at least 1.5 times greater than a typical modern human male. Some estimates suggest their arm strength could have been twice that of even trained modern athletes. Their grip strength would have been off the charts by our standards. A modern human male typically has a grip strength of around 80 to 120 pounds of pressure. The average Neanderthal, likely well over 200 pounds of crushing force in each hand. They could have easily crushed objects that would require modern humans to use tools. This extraordinary physical power wasn't just for show, it was essential for their survival strategy. Unlike later human groups who developed specialized projectile weapons that could kill from a distance, Neanderthals were close combat hunters. They crafted heavy thrusting spears designed not to be thrown, but to be driven directly into large, dangerous prey at close range. Just think about that for a moment. Neanderthals were hunting animals like woolly rhinos, cave bears, and mammoths, massive beasts that could easily kill a human, and they were doing it up close and personal. This wasn't because they couldn't conceive of better hunting methods. It was a deliberate strategy that played to their physical strengths and was perfectly adapted to the environments where they lived. The physical evidence of this high-risk hunting strategy is written in their bones. Neanderthal skeletons show patterns of injury that have been compared to those seen in modern rodeo riders. They have healed fractures distributed across their bodies, especially in the head, neck and upper body, exactly the pattern you'd expect from close encounters with large, dangerous animals. One study found that about 80% of Neanderthal adults showed evidence of at least one significant healed injury. The most famous example is the Old Man of La Chapelle-aux-Saints, a Neanderthal who lived to around 40 years of age, elderly by Paleolithic standards. His skeleton shows multiple healed injuries, including broken ribs, a crushed toe, knee damage, and dental abscesses. Despite these injuries, he survived for years afterward, suggesting his community cared for him during recovery. This wasn't a gentle world they lived in, and their bodies show they confronted that harshness head-on. Their strength and hunting strategy were only part of what made Neanderthals exceptional. Their bodies were also perfectly adapted to survive extreme cold in ways that went far beyond just having bigger noses. Their entire body proportion was different from ours in ways that maximized heat retention. Modern humans evolved in Africa and have body proportions suited to heat dissipation, long limbs with a high surface area to volume ratio that helps release excess heat. Neanderthals evolved the opposite body type. They had shorter limbs and stockier builds, reducing the surface area through which they could lose heat. This gave them a physique similar to modern humans who live in extremely cold environments like traditional Inuit populations, but even more pronounced. This adaptation to cold wasn't just about staying comfortable, it was about survival. When temperatures plunged during glacial periods, the Neanderthals' compact muscular bodies would have been significantly more efficient at retaining heat than the bodies of modern humans. This meant they could survive with less technological assistance, fewer layers of clothing, less fuel needed for fires, and less food required to maintain body temperature. Speaking of food, Neanderthals needed a lot of it. Their powerful muscles, larger brains, and the cold environments they inhabited all required tremendous caloric intake. Scientists estimate that Neanderthals would have needed anywhere from 3,500 to 5,000 calories daily, roughly twice what a sedentary modern human consumes and comparable to what Olympic athletes eat during training. Where did all these calories come from? Primarily, they came from meat. Isotope analysis of Neanderthal bones shows they were top-level carnivores, getting most of their protein from large herbivores like deer, bison, wild horses, and even woolly rhinoceros and mammoths. In many locations, they appear to have specialized in hunting reindeer during seasonal migrations, intercepting the herds at strategic points in the landscape. This doesn't mean they never ate plants. Recent studies of dental plaque from Neanderthal teeth have revealed evidence of various plant foods, including grains, tubers, and even medicinal plants. But the overall picture that emerges is of a diet heavily dominated by meat, especially in northern regions during colder periods when plant foods would have been scarce. This meat-heavy diet wasn't just a choice, it was a necessity dictated by their environment and metabolism. The bitter cold of glacial Europe meant plant foods were seasonal and limited, high-energy animal products. Not just muscle meat, but fat, marrow, and organ meats provided the concentrated calories Neanderthals needed to power their robust bodies through harsh winters. How they got all this meat is a testament to their extraordinary physical capabilities and hunting prowess. The archaeological evidence from Neanderthal sites shows they were skilled and strategic hunters who could take down the largest and most dangerous prey animals of Ice Age Europe. At sites across Europe, archaeologists have found the butchered remains of everything from reindeer and wild horses to woolly rhinoceros and even young mammoths. The distribution of cut marks on these bones shows the Neanderthals weren't just scavenging, they were systematically breaking down complete carcasses, extracting not just meat but valuable fat, marrow, and other nutrients. In some locations, like the site of Moran in France, evidence suggests Neanderthals engaged in mass killings of bison, driving herds into natural traps where they could be efficiently slaughtered. At La Côte de Saint-Brelade in Jersey, an island in the English Channel, archaeologists found evidence that Neanderthals may have driven mammoth herds off cliffs as a hunting strategy. But these were not simple, opportunistic hunters. The evidence shows they understood animal behavior and planned their hunts carefully. At many sites, the remains show a focus on prime-aged adult animals, the most dangerous but also the most nutritious targets. This selective hunting strategy required not just physical power, but sophisticated knowledge and planning. Their hunting technology, while not as diverse as that of later humans, was remarkably effective for their needs. Wooden spears found at Schöningen in Germany, dating to around 300,000 years ago, show these weren't crude sticks but carefully crafted weapons. The spears were made from spruce wood, with the weight perfectly balanced toward the front, similar to modern javelins. The tips were hardened by careful charring, creating weapons that could penetrate the thick hides of large animals. More surprising to many researchers was the discovery that Neanderthals sometimes used ranged weapons. At the site of Abri-du-Marat in France, microscopic analysis of stone points showed impact damage and traces of binding materials that suggest they were used as projectile tips, possibly for thrown spears. While not as advanced as the bows and atlatls of later humans, these findings show Neanderthals weren't limited to close-quarters combat. Perhaps most impressive was their mastery of adhesive technology. At multiple sites across Europe, researchers have found evidence that Neanderthals created complex adhesives using birch bark tar, a process that requires carefully controlled heating to extract the sticky resin without burning it. They used these adhesives to attach stone points to wooden shafts, creating more effective composite tools. The process of creating birch bark tar is so complex that some archaeologists have attempted to recreate it using only technologies available to Neanderthals with limited success. The physical demands of the Neanderthal lifestyle left their mark on their skeletons in another way: asymmetry. Studies of Neanderthal arm bones show they typically had significantly stronger right arms than left, a pattern consistent with repeatedly performing powerful right-handed thrusting motions. This fits perfectly with what we know about their hunting techniques and provides further evidence that their extraordinary strength wasn't just genetic, it was developed through a lifetime of intense physical activity. We shouldn't think of Neanderthals as simply stronger versions of ourselves. Their entire physiology was different, adapted to meet the demands of their lifestyle and environment. Their muscle fiber composition likely differed from ours, with a higher proportion of fast-twitch fibers that generate explosive power rather than endurance. Their metabolic rates were higher, their cardiovascular systems more efficient at delivering oxygen during intense activity, and their bodies better at conserving heat in frigid conditions. These weren't primitive traits, they were specialized adaptations that made Neanderthals incredibly successful in their ecological niche. For over 300,000 years, they thrived in environments ranging from the Mediterranean to the edge of the Arctic, surviving multiple glacial cycles and rapid climate shifts that would have challenged even technologically equipped modern humans. But their physical prowess wasn't the only remarkable thing about them. Perhaps the most surprising aspect of Neanderthal biology, and the one that has forced scientists to completely reconsider our view of these ancient humans, was their brains. For decades, the scientific consensus held that Neanderthals were intellectually inferior to modern humans. Their distinctive skull shape, with its elongated form and pronounced brow ridge, was taken as evidence of primitive cognitive abilities. But as more complete Neanderthal skulls were discovered and analysed, a surprising fact emerged: their brains were actually larger than ours. The average Neanderthal brain volume was around 1,600 cubic centimetres compared to about 1,400 cubic centimetres for modern humans. Some Neanderthal specimens had brains as large as 1,740 cubic centimetres, well beyond the size of even the largest modern human brains. Brain size isn't everything, of course. The internal organisation matters too, but here again, detailed studies of Neanderthal skull endocasts, models of the brain based on the internal shape of the skull, have revealed surprising sophistication. While their brains were organised somewhat differently than ours, with relatively larger areas devoted to vision and body control, they still had well-developed frontal lobes, the areas associated with planning, decision-making, and social cognition. The implications are clear. Neanderthals weren't cognitively inferior to modern humans. They were just different. Their brains were adapted for the specific challenges of their lifestyle and environment, with enhanced capabilities in areas like spatial awareness, visual processing, and motor control, all critical for hunters navigating complex terrain and engaging dangerous prey at close quarters. This neural difference extended to their sensory capabilities as well. Studies of Neanderthal skulls suggest they had larger eye sockets than modern humans, potentially indicating larger eyes and enhanced visual capabilities, particularly in low-light conditions. This would have been a significant advantage for hunters in the forests of Europe, especially during the long winters when daylight was limited. Their sense of smell was likely different too. The structure of the Neanderthal nasal cavity suggests they may have had a more acute sense of smell than modern humans, another advantage for hunters who needed to track prey and detect potential dangers in their environment. Even their hearing may have been adapted to their lifestyle. Studies of Neanderthal ear bones suggest they may have had different auditory capabilities than modern humans, potentially with enhanced sensitivity to certain frequency ranges that would have been useful for detecting prey or communicating in forested environments. All these sensory adaptations paint a picture not of primitive brutes but of highly specialized humans whose entire biology was exquisitely adapted to the demands of life as Ice Age hunters in European forests and steppes. And the evidence for their cognitive sophistication goes far beyond just their brain size. The archaeological record shows Neanderthals engaged in behaviors that were once thought to be exclusive to modern humans, behaviors that require abstract thinking, planning, and cultural transmission. They controlled fire not just for warmth but for cooking, transforming tough, fibrous foods into more digestible forms and potentially unlocking more calories from their diet. They crafted complex tools that required multiple steps to produce, including composite tools that combined different materials. They cared for their injured and elderly, as shown by numerous skeletons with healed injuries that would have required long-term care to survive. Most surprisingly to many researchers, they created art and symbolic objects. At sites across Europe, archaeologists have found evidence of Neanderthal artistic expression, pigments processed for use as colorants, shell beads apparently used as ornaments, and even cave paintings that predate the arrival of modern humans in Europe. At Bruniquel Cave in France, archaeologists discovered something truly extraordinary, a circular structure made from broken stalagmites located deep within the cave where no natural light could reach, dated to 176,000 years ago, when only Neanderthals inhabited Europe. This structure suggests they were venturing deep into caves, controlling fire for illumination and creating organized structures for purposes we can only guess at, perhaps ritual, perhaps social. These weren't the actions of simple brutes, they were the behaviors of complex, intelligent beings with rich social lives and cultural traditions, and they force us to completely reconsider our understanding of who the Neanderthals were. So, if Neanderthals were so physically powerful, so well adapted to their environment, and so cognitively sophisticated, why did they disappear? Why did our ancestors, with their more fragile bodies and similar brain sizes, survive while the mighty Neanderthals vanished? The answer isn't simple, and scientists are still debating the exact causes of Neanderthal extinction, but several factors likely contributed to their demise. One key factor was climate change. Around 40,000 years ago, Europe experienced a series of rapid, extreme climate fluctuations known as Heinrich events. These sudden cold snaps would have dramatically altered the ecosystems Neanderthals relied on, potentially reducing the populations of their preferred prey species and making their high-calorie, meat-heavy diet harder to sustain. Another factor was the arrival of modern humans in Europe beginning around 45,000 years ago. These newcomers brought different technologies, different hunting strategies, and possibly different social structures that may have given them competitive advantages in certain environments. There's little evidence for direct violence between Neanderthals and modern humans, no mass graves or skeletons with weapon injuries that would suggest warfare or genocide, but competition for resources, even peaceful competition, could have slowly pushed Neanderthal populations into decline. Disease may have played a role too. Modern humans migrating from Africa likely carried pathogens that Neanderthals had never been exposed to and had no immunity against. These novel diseases could have devastated Neanderthal populations already stressed by climate change and competition. Perhaps most intriguingly, we now know that Neanderthals didn't completely disappear. Genetic studies of modern human populations outside of Africa reveal that most of us carry between 1 and 4% Neanderthal DNA in our genomes, clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. This interbreeding suggests that rather than being replaced entirely, Neanderthals may have been partially absorbed into the expanding modern human population. As their numbers dwindled due to climate change and competition, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The story of the Neanderthals is not, therefore, simply one of failure and extinction. It's a complex tale of adaptation, resilience, and ultimately transformation. Their physical power and specialized adaptations made them extraordinarily successful for hundreds of thousands of years, far longer than our species has existed, and elements of their biology live on in many of us today. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkable beings whose physical capabilities and adaptations allowed them to thrive in some of the harshest environments on Earth. Their story reminds us that there are many ways to be human, many paths that our evolution might have taken. As we've seen, Neanderthals were true physical freaks of nature. Their bones were stronger, their muscles more powerful, their bodies more resilient to cold and injury than ours could ever be. They were specialized survival machines, perfectly adapted to the demands of Ice Age Europe. But their story is far from complete. As new discoveries are made and new analytical techniques developed, our understanding of these remarkable humans continues to evolve. And as we'll see in the next part of our exploration, their physical prowess was matched by cognitive and technological abilities that force us to completely reconsider who they were and how they lived. The evidence is clear. Neanderthals weren't primitive brutes. They were sophisticated, powerful humans whose biology and culture were perfectly adapted to survive and thrive in the challenging environments of Ice Age Europe. Their extraordinary physical strength was just one aspect of a complex and successful adaptation that allowed them to dominate Europe for hundreds of thousands of years. In the next part of our exploration, we'll delve deeper into the Neanderthal mind, their cognitive abilities, their technological innovations, and the evidence for complex social and cultural behaviors that paint a picture far different from the stereotypical grunting cavemen of popular imagination. And we'll discover that in many ways they weren't so different from us after all. We've established that Neanderthals were physical powerhouses, stronger, more robust, and perfectly adapted to survive in frigid environments that would kill most modern humans within days. But their extraordinary nature goes far beyond just brute strength. Their brains and cognitive abilities challenge everything we thought we knew about these ancient humans. For decades, the scientific narrative portrayed Neanderthals as intellectually inferior to modern humans, bigger and stronger, yes, but lacking the mental sophistication that supposedly allowed Homo sapiens to outcompete them. This convenient story positioned our ancestors as the rightful inheritors of the planet, destined to replace their more primitive cousins through superior intelligence. But recent discoveries have completely demolished this self-serving myth. Neanderthals weren't just muscular brutes, they were sophisticated beings with large brains, complex technology, and social structures that allowed them to thrive for hundreds of thousands of years in environments we can barely survive in with all our modern technology. Let's start with the most surprising fact. Neanderthals had bigger brains than we do. The average Neanderthal brain volume was approximately 1,600 cubic centimeters compared to about 1,400 cubic centimeters for modern humans. Some Neanderthal specimens had brains as large as 1,700 cubic centimeters, well beyond the range of even the largest modern human brains. Size isn't everything when it comes to brains, of course. The internal organisation matters tremendously, and here's where things get really interesting. Detailed studies of Neanderthal skull endocasts, models of the brain based on the internal shape of the skull, reveal that their brains were organised differently than ours, but not in the way you might expect. Neanderthals had proportionally larger visual cortices, the parts of the brain responsible for processing visual information. This enhanced visual processing capacity would have been tremendously advantageous for hunters operating in the varied landscapes of Ice Age Europe, allowing them to spot prey at greater distances and in lower light conditions than modern humans could manage. They also devoted more neural resources to body control and somatosensory processing, the parts of the brain that govern movement and physical sensation. This makes perfect sense given their highly physical lifestyle and hunting techniques that required precise control of powerful movements. What's fascinating is that when researchers account for these differences in brain organization, they find that the remaining higher cognitive areas of the Neanderthal brain were comparable in size to those of modern humans. Their frontal lobes, the parts of the brain associated with planning, decision-making, and social cognition, were well developed, suggesting cognitive capabilities similar to our own. But the most compelling evidence for Neanderthal cognitive sophistication comes not from their brain anatomy, but from what they actually did, the archaeological record of their behaviours and technologies. And this evidence is forcing scientists to completely reconsider who these ancient humans were. Consider their technological achievements. For over 150 years, the Mousterian stone tool industry, the distinctive tool-making tradition associated with Neanderthals, was considered relatively simple and static compared to the rapidly evolving technologies of early modern humans. But closer examination reveals a level of sophistication that demands respect. Neanderthals were masters of what's called the Levallois technique, a method of stone tool production that requires careful planning and precise execution. The technique involves preparing a stone core in a specific way to control the shape and size of the resulting flakes, creating tools with predetermined forms perfectly suited for specific tasks. This isn't simple banging rocks together. It requires abstract thinking, the ability to visualize the finished tool within the raw stone, and precise motor control to execute the necessary strikes. Modern experimental archaeologists who attempt to recreate these tools often require years of practice to achieve the level of skill evident in even average Neanderthal tools. And their technological prowess went far beyond just knapping stone. At multiple sites across Europe, archaeologists have found evidence that Neanderthals created and used complex adhesives to attach stone points to wooden shafts, creating more effective composite tools. The most common adhesive was birch bark tar, a substance that requires a sophisticated multi-stage production process. To create birch bark tar, Neanderthals had to carefully heat birch bark in a low-oxygen environment at controlled temperatures. Too cool and the tar won't form, too hot and it will simply burn. This process requires not just fire control, but an understanding of pyrotechnology that was once thought to be exclusive to modern humans. The complexity of this process is so great that modern archaeologists have struggled to recreate it using only technologies available to Neanderthals. The fact that Neanderthals routinely produced these adhesives across Europe for tens of thousands of years speaks volumes about their cognitive capabilities and technological know-how. Their mastery of fire extends beyond just adhesive production. Evidence from Neanderthal sites shows they strategically placed hearths within their living spaces, controlled fire temperatures for different purposes, and likely used fire not just for warmth but for cooking, hardening wooden tools, and possibly even for ritual purposes. At the site of Abric Romani in Spain, archaeologists found evidence of multiple hearths arranged in what appears to be a purposeful layout within a living space, suggesting Neanderthals were organizing their living environments in complex ways. The hearths were positioned to create different activity areas, some for tool making, others for food processing, others perhaps for sleeping. Their toolkit wasn't limited to stone and wood either. At several sites, archaeologists have found evidence of bone tools, implements crafted from animal bones that were shaped and polished for specific purposes. At Abri-Peyroney and Pech-de-la-Zay in France, researchers discovered Neanderthal bone tools called lissoirs, specialized implements used to work animal hides, making them more supple and water-resistant. What's remarkable about these tools is that they represent the first documented instance of a technology that would later become common among modern humans. This isn't a case of Neanderthals copying modern human technology. These bone tools predate the arrival of modern humans in the region by thousands of years. It's a clear case of independent invention, further evidence of Neanderthal cognitive sophistication and technological innovation. Even more surprising was the discovery in 2020 of direct evidence of fiber technology used by Neanderthals. At the site of Abri-du-Marat in France, researchers found a 3-ply cord fragment made from inner bark fibers dating to between 41 and 52,000 years ago, the oldest direct evidence of string or cord making ever discovered. The significance of this find can't be overstated. Creating twisted fiber cordage requires understanding of multiple concepts: how materials can be processed to extract usable fibers, how those fibers can be twisted to create stronger strands, and how those strands can be combined to create even stronger cord. It implies a mathematical understanding of patterns and processes that was once thought to be uniquely human. And cordage isn't just significant as a technology in itself, it's the foundation for numerous other technologies. Ropes, nets, bags, clothing, shelter components all depend on the ability to create and use cordage. The presence of this technology suggests Neanderthals may have had access to a whole range of complex tools and equipment that simply haven't preserved in the archaeological record. We've long known that Neanderthals were expert hunters, but recent research has revealed just how sophisticated their hunting strategies were. Far from being simple opportunistic predators, Neanderthals employed complex planned hunting tactics that required intimate knowledge of animal behavior and landscape features. At sites across Europe, the evidence shows Neanderthals strategically positioned themselves to intercept migrating herds at natural bottlenecks in the landscape, places where the terrain would concentrate animals and make them more vulnerable. They appear to have coordinated group hunts, with different individuals playing different roles in the pursuit and takedown of dangerous prey. Some sites suggest they employed drive hunting techniques where groups of hunters would work together to channel animals toward ambush points or natural traps like ravines or swampy areas. This kind of coordinated hunting requires not just physical prowess, but communication, planning, and shared knowledge of both the terrain and the behavior of prey species. The sophistication of their hunting is reflected in their prey selection. Studies of animal remains from Neanderthal sites show they weren't just taking whatever animals they happened to encounter. They were selectively targeting prime-aged adult animals, the ones in their physical prime that would provide the most nutritional benefit despite being the most dangerous to hunt. This kind of selective hunting isn't the behavior of simple-minded brutes. It reflects complex decision-making that weighs risks against benefits and requires extensive knowledge passed down through generations. It's the behavior of sophisticated hunter-gatherers with rich cultural traditions and deep ecological understanding. Their ecological knowledge extended beyond just hunting. Analysis of plant remains and residues from Neanderthal sites shows they exploited a wide range of plant resources for food, medicine, and materials. They weren't just meat-eaters, they were knowledgeable foragers who understood which plants were edible, which had medicinal properties, and which could be used for technological purposes. At the site of Shanidar Cave in Iraq, scientists found pollen concentrations around a Neanderthal burial that suggest flowers may have been placed with the body. While the flower burial interpretation has been debated, the presence of these plant remains demonstrates that Neanderthals were interacting with plants in complex ways beyond just basic subsistence. More compelling is the evidence from dental calculus, the hardened plaque on Neanderthal teeth. Analysis of this material has revealed traces of numerous plant species, including some with medicinal properties. One particularly striking example comes from El Cidrón Cave in Spain, where researchers found evidence that a Neanderthal with a dental abscess appears to have been consuming plants with antibiotic properties, suggesting they understood not just which plants were edible, but which could be used to treat specific ailments. This kind of sophisticated ethnobotanical knowledge, understanding which plants can be used for which purposes, requires not just individual learning but cultural transmission across generations. It's yet another line of evidence pointing to complex Neanderthal societies with accumulated knowledge and traditions. Perhaps the most surprising and controversial aspect of Neanderthal behavior is their apparent capacity for symbolic expression, art, ornaments, and potentially ritual practices that were once thought to be exclusively human traits. For decades, the scientific consensus held that symbolic behavior emerged suddenly with modern humans, representing a cognitive leap that separated us from all other hominins. But evidence from Neanderthal sites is challenging this narrative. At multiple sites across Europe, archaeologists have found evidence that Neanderthals collected and processed coloured pigments like red and yellow ochre. These materials had no obvious practical use, but may have been used for body decoration, colouring animal hides, or creating visual symbols. At Cueva de los Aviones in Spain, researchers found perforated seashells stained with pigments that appear to have been worn as ornaments, dating to over 115,000 years ago, long before modern humans arrived in the region. Similar finds from other sites suggest this wasn't an isolated occurrence, but a widespread Neanderthal practice. Even more astonishing is the evidence for Neanderthal cave art. At La Pasiega Cave in Spain, a ladder-like symbol painted in red ochre has been dated to more than 64,000 years ago, at least 20,000 years before modern humans arrived in Europe. Similar dates have been obtained for hand stencils at Maltravieso Cave and a red geometric symbol at Ardales Cave, both in Spain. If these dates are accurate, and they remain controversial among some researchers, they provide clear evidence that Neanderthals were creating symbolic representations long before they encountered modern humans. This would be a dramatic refutation of the idea that symbolic thought was unique to Homo sapiens. Less controversial but equally significant is the evidence for Neanderthal constructions deep within cave systems. At Bruniquel Cave in France, archaeologists discovered a circular structure made from deliberately broken stalagmites located more than 300 meters from the cave entrance in complete darkness. This structure has been dated to 176,000 years ago, when only Neanderthals inhabited Europe. The implications are profound. Creating this structure would have required not just planning and cooperation, but artificial light. Neanderthals would have had to maintain and control fire as they ventured deep into the cave, and the purpose of the structure remains mysterious. It shows no evidence of habitation or practical use, suggesting it may have had ritual or symbolic significance. These aren't the actions of simple, instinct-driven brutes. They're the behaviors of beings with complex inner lives, beings capable of abstract thought, symbolic representation, and potentially spiritual or ritualistic practices. Perhaps the most humanizing aspect of Neanderthal behavior is their apparent care for one another. Multiple Neanderthal skeletons have been found with evidence of serious injuries and disabilities that had healed before death, individuals who could only have survived with the support and care of their community. The famous Old Man of La Chapelle-aux-Saints is a classic example. This elderly Neanderthal had severe arthritis, a damaged hip, missing teeth, and other pathologies that would have made it difficult for him to contribute to hunting or other physically demanding tasks. Yet he survived to an age that was advanced by Paleolithic standards, suggesting his community continued to care for him despite his limited productivity. Similar cases have been found at other sites, individuals with serious injuries or congenital deformities who survived for years after becoming disabled. This isn't the behavior of creatures concerned only with immediate survival. It's evidence of social bonds, compassion, and a recognition of the value of individuals beyond their immediate utility, quintessentially human traits. And then there are the burials. At multiple sites across Europe and the Middle East, archaeologists have found Neanderthal remains in positions and contexts that strongly suggest intentional burial. The bodies were placed in natural or artificially created depressions, sometimes in flexed positions, and occasionally with what appear to be grave goods, objects placed with the deceased. At Shanidar Cave in Iraq, several Neanderthal burials have been discovered, including the famous flower burial mentioned earlier. While the interpretation of flowers being deliberately placed with the body remains controversial, the deliberate burial itself is not in doubt. More recent excavations at La Chapelle-aux-Saints in France have strengthened the case for Neanderthal burials. Careful re-examination of the site has revealed clear evidence of a deliberately dug pit in which the body was placed, not simply a natural depression as some skeptics had suggested. Intentional burial of the dead implies not just practical concerns about hygiene or predators, but conceptual thinking about death, possibly beliefs about an afterlife, and certainly emotional attachments to deceased community members. It's one of the clearest indicators that Neanderthals possessed a mental and emotional life comparable to our own. All of this evidence, from their technology to their art, from their ecological knowledge to their care for the injured, paints a picture of Neanderthals as sophisticated beings with rich cultural traditions and complex social lives. They weren't lesser versions of us. They were a different expression of humanity, adapted to different circumstances, but no less intelligent or capable. So, if they were so capable, why did they disappear while our ancestors thrived? The answer is complex and still debated, but it likely involves a combination of factors rather than any single decisive advantage possessed by modern humans. Climate change clearly played a role. Around 40,000 years ago, Europe experienced a series of rapid, severe climate fluctuations, sudden cold snaps followed by brief warming periods. These dramatic shifts would have stressed the ecosystems Neanderthals relied on, potentially reducing prey populations and making their high-calorie, meat-dependent diet more difficult to maintain. Modern humans, with their slightly different technological toolkit and potentially more flexible subsistence strategies, may have been better equipped to weather these changes. Evidence suggests early modern humans exploited a broader range of food resources, including small game and aquatic foods that appear less frequently in Neanderthal sites. But it wasn't just about technology or subsistence. Demographic factors likely played a crucial role. Genetic studies of Neanderthal remains suggest they maintained relatively small, isolated populations with limited genetic diversity. This would have made them vulnerable to inbreeding, depression, reduced fitness due to the accumulation of harmful genetic variants. Modern humans, in contrast, appear to have maintained larger, more connected population networks with more genetic mixing between groups. This demographic structure would have provided greater resilience in the face of environmental challenges and potential competitive advantages in resource-rich areas. Disease may have been another factor. Modern humans migrating from Africa would have carried pathogens that Neanderthals had never been exposed to and had no immunity against. These novel diseases could have had devastating effects on Neanderthal populations already stressed by climate change and competition. And competition, while perhaps not taking the form of direct violence, was likely significant. As modern human populations expanded into Europe, they would have increasingly competed with Neanderthals for key resources, prime hunting territories, sheltered cave sites, high-quality stone for tools. Even without conflict, this competition could have slowly pushed Neanderthal populations into decline. But perhaps the most intriguing aspect of the Neanderthal disappearance is that they didn't completely vanish. Genetic studies have revealed that most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. Clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. This interbreeding suggests that rather than being completely replaced, Neanderthals may have been partially absorbed into the expanding modern human population. As their numbers dwindled due to the factors discussed above, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The genetic legacy of these interbreeding events remains with us today. Some Neanderthal gene variants appear to have been advantageous for modern humans moving into the colder environments of Eurasia. Genes involved in skin and hair characteristics, fat metabolism, and immune responses to European pathogens. These beneficial variants were retained by natural selection and remain part of our genetic makeup. Other Neanderthal variants were apparently detrimental and were gradually purged from the human genome. These include genes on the X chromosome, suggesting male hybrid offspring may have had reduced fertility, and genes involved in certain aspects of brain development. This selective retention and elimination of Neanderthal DNA has shaped the human genome in complex ways that we're only beginning to understand. So, the story of the Neanderthals isn't simply one of inferior beings replaced by superior ones. It's a complex tale of two human species, both highly intelligent, both capable of remarkable technological and cultural achievements, facing the challenges of a rapidly changing world with different biological and cultural adaptations. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who thrived in some of the most challenging environments on Earth for hundreds of thousands of years, far longer than our species has existed. Their physical and cognitive adaptations allowed them to dominate Ice Age Europe in ways we can barely imagine, and elements of their biology live on in many of us today. As we continue to discover more about these extraordinary beings, our appreciation for their capabilities only grows. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more nuanced and respectful understanding of who the Neanderthals really were. They weren't just freaks of nature in terms of their physical strength. They were sophisticated, intelligent beings with rich cultural traditions, complex technologies, and social lives not so different from our own. Their story isn't a sidebar in human evolution. It's a parallel narrative of a different but equally valid way of being human. And as we'll explore in the next part of our journey, the Neanderthals' remarkable adaptations extended far beyond their bodies and brains to encompass complex social structures and cultural innovations that allowed them to thrive in environments we can barely survive in today. Their story continues to unfold as new discoveries reveal more about these extraordinary humans who walked alongside our ancestors through the Ice Age landscapes of ancient Europe. We've explored the extraordinary physical prowess of Neanderthals, their immense strength, cold-adapted bodies, and specialized hunting capabilities. We've examined their remarkable brains and cognitive abilities, larger than our own, organized differently, but clearly capable of sophisticated thought and innovation. Now, let's delve even deeper into what truly made Neanderthals such remarkable beings. Their social structures, survival strategies, and the astonishing technologies they developed to thrive in the harshest environments Earth has ever produced. Imagine yourself transported back 40,000 years to the depths of the last ice age in Europe. You're standing on a windswept plain in what will someday become southern France. The temperature hovers around -20 degrees Celsius. The wind cuts like a knife. The landscape is a treeless steppe stretching to the horizon, broken only by the occasional rocky outcrop. There are no buildings, no roads, no power lines. Nothing of the modern world exists. Just you, the cold and the unforgiving wilderness. Without modern technology, without Gore-Tex jackets, insulated boots, GPS devices and emergency services, how long would you survive? Hours, perhaps a day or two at most? This was the world of the Neanderthals, not just for a weekend camping trip or a survival challenge, but for their entire lives, generation after generation, for hundreds of thousands of years. And they didn't just survive in these conditions, they thrived, they hunted, they raised families, they created art and technology, they lived full, complex lives in environments that would kill most modern humans within days. How did they do it? The answer lies not just in their physical adaptations, though those were certainly crucial, but in their social structures, their accumulated knowledge, and the sophisticated technologies they developed, technologies that have only recently begun to receive the recognition they deserve. Let's start with their living spaces. The popular image of Neanderthals as cave dwellers isn't entirely wrong. They did frequently use caves and rock shelters as bases, especially in colder regions and during winter months, but archaeological evidence shows they were far more sophisticated in their use of these spaces than previously thought. At sites across Europe, archaeologists have found evidence of structured living areas within caves, spaces organised for different activities, with hearths strategically placed for warmth, cooking and light. At a brick Romani in Spain, researchers discovered the remains of wooden platforms that appear to have been used as sleeping areas, raised off the cold, damp cave floor. These weren't just random nests, they were deliberately constructed fixtures within a well-organised living space. But Neanderthals weren't confined to caves. At open-air sites like Moldova in Ukraine, archaeologists have found evidence of constructed dwellings, structures built using mammoth bones as foundations and supports, likely covered with hides to create sheltered living spaces, even in areas without natural caves. These structures weren't temporary overnight shelters, they show evidence of repeated use and maintenance over time. What's particularly impressive about these living spaces is the evidence they provide for long-term planning and resource management. Neanderthals weren't just reacting to immediate needs, they were anticipating future requirements and preparing accordingly. They stockpiled materials for fires, gathered tools and resources, and created spaces that could support extended periods of occupation during the harshest seasons. This kind of foresight extends to their food acquisition strategies as well. Far from being opportunistic scavengers or simple hunters taking whatever prey they happened to encounter, Neanderthals employed sophisticated strategies that required intimate knowledge of animal behavior and landscape features. Studies of animal remains from Neanderthal sites reveal patterns that speak to highly organized hunting practices. At many sites, the bones show a focus on specific prey species during particular seasons: reindeer during autumn migrations, ibex during summer months when they descended to lower elevations, bison when they congregated in valleys during winter. This selective hunting required not just tracking skills, but an understanding of animal migration patterns and seasonal behaviors. The evidence also shows they were transporting specific parts of animals back to their living sites, the most nutritionally valuable portions that provided the highest return for the energy expended in carrying them. This kind of selective transport isn't random or instinctive. It reflects calculated decisions about resource efficiency, another sign of sophisticated planning and knowledge. Perhaps most impressive is the evidence for communal hunting techniques. At sites like La Côte de Saint-Brelade in Jersey, an island in the English Channel, archaeologists found the remains of dozens of mammoths and rhinoceroses at the base of a cliff. The pattern of these remains suggests Neanderthals were driving herds toward the cliff edge, causing them to fall to their deaths, a hunting technique that would have required coordination among multiple individuals playing different roles. Similar evidence for cooperative hunting has been found at sites across Europe. These weren't solitary hunters, but coordinated groups working together to take down prey that no individual could handle alone. This kind of cooperation required communication, planning, and social bonds, all hallmarks of complex social structures. And these social structures extended beyond just hunting parties. Multiple lines of evidence suggest Neanderthals lived in small, close-knit groups with strong social bonds and mutual support systems. The care for injured individuals discussed earlier, those who survived serious injuries that would have prevented them from contributing to hunting or other physically demanding tasks, demonstrate social commitments that transcended immediate utility. The size of these groups has been estimated based on the dimensions of living spaces and resource availability in different environments. In most regions, Neanderthals appear to have lived in bands of perhaps 10 to 20 individuals, extended family groups that stayed together year-round, sharing resources and knowledge. These bands weren't completely isolated, however. The distribution of distinctive stone tools and raw materials suggests networks of interaction between different Neanderthal groups across substantial distances. High-quality stone was sometimes transported or traded over distances of 50 kilometers or more, indicating contact and exchange between different bands. Within these groups, there's evidence for division of labor and specialized roles. Patterns of wear and injury on Neanderthal skeletons suggest some individuals consistently performed certain tasks. Some focused more on hunting, others perhaps on processing hides or creating tools. This kind of specialization allows groups to accomplish more than if everyone were a generalist, and it's another indicator of social complexity. There's even tantalizing evidence for distinct cultural traditions among different Neanderthal groups, regional variations in tool-making techniques, resource exploitation strategies, and possibly symbolic practices. These weren't just instinctive behaviors shared by all members of the species, but learned traditions passed down through generations within specific communities. This cultural transmission, the passing of knowledge from one generation to the next, is perhaps one of the most distinctively human aspects of Neanderthal life. The complexity of their technologies and hunting strategies couldn't have been reinvented by each individual or even each generation. They represent accumulated knowledge built up over thousands of years and preserved through teaching and learning within social groups. Consider their technological achievements. The sophistication of Neanderthal stone tools has long been recognized, but recent research has revealed they were capable of much more than just knapping flint. They created composite tools, implements combining different materials like stone, wood, and adhesives to create more effective weapons and tools than could be made from any single material. The production of birch bark tar adhesive, mentioned earlier, is particularly impressive. Creating this substance requires a complex, multi-stage process involving the careful application of heat in a low-oxygen environment. The tar must then be processed and applied while still warm to cool, and it becomes brittle and unusable. This technology requires not just knowledge of materials, but precise control of temperature and timing. Experimental archaeologists have attempted to recreate this process using only technologies available to Neanderthals with limited success. The fact that Neanderthals routinely produced these adhesives across Europe for tens of thousands of years speaks volumes about their technological sophistication and the depth of their cultural knowledge. They weren't just making tools, they were engaging in complex manufacturing processes that required planning, precision, and specialized knowledge. This isn't the behavior of simple brutes acting on instinct. It's the work of intelligent beings with rich cultural traditions and accumulated technical expertise. Their technological prowess extended to fibers and cordage as well. The discovery of a 3-ply cord fragment at Abri-du-Maras in France, mentioned earlier, indicates they understood how to process plant materials to extract usable fibers, how to twist those fibers to create stronger strands, and how to combine those strands to create even more robust cord. This might seem like a simple technology to modernize, but it represents a fundamental innovation that underlies countless other technologies. Cordage is the foundation for nets, bags, snares, fishing lines, and components of complex tools like bows. It's a transformative technology that vastly expands what humans can accomplish, and Neanderthals mastered it tens of thousands of years ago. The evidence for fiber technology raises intriguing questions about what other perishable technologies Neanderthals might have developed. Did they create basketry, woven mats, nets for fishing or trapping small game? The cordage fragment suggests these possibilities, though direct evidence is scarce due to the poor preservation of organic materials in most archaeological contexts. We do know they processed animal hides to create what were likely clothing and shelter components. At multiple Neanderthal sites, archaeologists have found specialized tools used for scraping and softening hides, indicating not just the use of animal skins for practical purposes, but a sophisticated understanding of how to transform raw hides into more useful materials. The bone tools discovered at Abri-Peyroni and Pech-de-la-Zay in France, the lissoirs or smoothers used for working hides, represent another level of technological refinement. These weren't simply stones picked up and used opportunistically, but carefully crafted implements designed for specific tasks. Their creation required selecting appropriate bones, shaping them to the desired form, and polishing them to create the smooth working surface necessary for effectively processing hides. This kind of specialized tool creation suggests not just technical knowledge, but specialized roles within Neanderthal societies, individuals who developed particular skills and perhaps focused on specific tasks. It's another indicator of social complexity and division of labor within their communities. Fire technology was another area where Neanderthals demonstrated remarkable sophistication. They weren't just using naturally occurring fires started by lightning strikes. They were creating and controlling fire for multiple purposes. Hearths found at Neanderthal sites show evidence of repeated use and maintenance, with different areas seemingly designated for different fire-related activities. They appear to have used fire not just for warmth and cooking, but for hardening wooden tools, processing birch bark tar, and potentially for ritual or social purposes. The structures found deep within Bruniquel Cave could only have been created with artificial light, indicating Neanderthals were able to transport and maintain fire even in challenging environments. The mastery of fire represents a transformative technology that dramatically expands what humans can accomplish. It extends the habitable day by providing light after sunset, allows for the occupation of colder environments by providing warmth, makes a wider range of foods digestible through cooking, and serves as a tool for transforming materials like wood and adhesives. Neanderthals weren't just using fire, they were exploiting its full potential as a multi-purpose technology. Their technological achievements weren't limited to material culture. They also developed sophisticated hunting and tracking techniques that allowed them to effectively exploit the challenging environments of Ice Age Europe. The evidence suggests they understood animal migration patterns, recognized seasonal changes in prey behavior, and strategically positioned themselves to intercept prey at vulnerable points in the landscape. They appear to have employed ambush hunting techniques, drive hunting strategies, and possibly trapping methods, each requiring different skills and knowledge. This wasn't instinctive behavior, but learned expertise, accumulated and refined over generations and passed down through teaching and observation. The variety of hunting techniques employed by Neanderthals suggests they were adapting their strategies to specific prey species and environmental conditions, not simply applying a one-size-fits-all approach. This kind of context-specific adaptation requires not just knowledge, but the ability to analyze situations and apply appropriate techniques, clear evidence of higher cognitive abilities. Their knowledge extended beyond hunting to broader ecological understanding. Analysis of plant remains from Neanderthal sites indicates they were exploiting a wide range of plant resources for food, medicine, and materials. They weren't just meat-eaters, but knowledgeable foragers who understood which plants were edible, which had medicinal properties, and which could be used for technological purposes. The evidence from El Sidrón Cave in Spain, where dental calculus from a Neanderthal with a dental abscess contained traces of plants with antibiotic properties, suggests they understood not just which plants were edible, but which could be used to treat specific ailments. This kind of medicinal knowledge represents another sophisticated cultural tradition that would have been built up over generations and passed down through social learning. All of these technological and knowledge systems, from tool-making to fire control, from hunting techniques to medicinal practices, represent cultural adaptations that allowed Neanderthals to thrive in environments that would quickly kill most modern humans without technological assistance. They weren't just surviving through physical adaptations, but through the accumulated wisdom of countless generations preserved and transmitted through social learning. This brings us to perhaps the most fascinating aspect of Neanderthal life, their apparent capacity for symbolic thought and expression. For decades, the scientific consensus held that symbolic behavior, art, ritual, ornaments, and other non-utilitarian expressions emerged suddenly with modern humans and represented a cognitive leap that separated us from all other hominins. But evidence from Neanderthal sites is challenging this narrative. The perforated and pigment-stained seashells from Cueva de los Aviones in Spain, dating to over 115,000 years ago, suggest Neanderthals were creating and wearing ornaments long before modern humans arrived in Europe. These weren't practical tools, but items of personal decoration, objects that likely held symbolic meaning within Neanderthal social contexts. The red ochre paintings in Spanish caves, the ladder-like symbol at La Pasiega, the hand stencils at Maltravieso, the geometric pattern at Ardales, dated to more than 64,000 years ago, suggest Neanderthals were creating visual symbols millennia before modern humans reached these regions. If these dates are accurate, they provide compelling evidence that symbolic expression wasn't unique to Homo sapiens, but was within the cognitive capabilities of Neanderthals as well. The circular structure deep within Brunichel Cave, created 176,000 years ago, represents perhaps the most enigmatic evidence for symbolic behavior. This arrangement of broken stalagmites, located far from the cave entrance in complete darkness, shows no evidence of practical use. It appears to have been created for purposes that transcended immediate utility, perhaps ritual, perhaps social, but clearly symbolic in nature. These aren't isolated findings, but part of a growing body of evidence suggesting Neanderthals possessed what might be called a symbolic mind, the capacity to assign meaning to objects and actions beyond their immediate practical value. This capacity underlies not just art and ornaments, but potentially language, ritual, and other complex social behaviors that we consider quintessentially human. The question of whether Neanderthals had language remains one of the most intriguing and challenging aspects of research into these ancient humans. Direct evidence is scarce, language leaves no fossils, but multiple lines of indirect evidence suggest they likely possessed complex communication systems. The anatomy of the Neanderthal vocal tract reconstructed from fossil remains indicates they were physically capable of producing a range of sounds similar to modern human speech. The hyoid bone, a small bone in the throat that supports the tongue and is crucial for speech production, from a Neanderthal at Kabara Cave in Israel, is virtually identical to that of modern humans. Genetic evidence is also suggestive. Neanderthals possessed the FOXP2 gene, often called the language gene, because mutations in this gene cause severe speech and language disorders in modern humans. The Neanderthal version of this gene was very similar to our own, suggesting they may have had similar language capabilities. But perhaps the most compelling evidence comes from the complexity of their social behaviors and technologies. The coordination required for cooperative hunting, the teaching necessary to transmit complex technological knowledge like birch bark tar production, the apparent division of labor within social groups. All these behaviors would be extremely difficult to accomplish without complex communication systems. Language isn't just about the physical ability to produce sounds, it's about the cognitive capacity to use symbols to represent concepts and to combine those symbols according to consistent rules. The evidence for symbolic thought in other domains, art, ornaments, possibly ritual, suggests Neanderthals possessed the cognitive foundations for language use. If they did have language, what might it have been like? We can only speculate, but given their environment and lifestyle, Neanderthal language might have been rich in terminology related to hunting, animal behavior, weather patterns, and landscape features. It might have included sophisticated ways to communicate about past events and future plans, essential for coordinating hunting strategies and seasonal movements. It likely included social language, ways to express relationships, emotions, and group identity. This brings us to another fascinating aspect of Neanderthal life, their emotional and spiritual worlds. The evidence for intentional burial of the dead discussed earlier suggests they had concepts about death and perhaps beliefs about an afterlife. The care for injured individuals indicates strong social bonds and empathy. The possible ritual structures like the one at Bruniquel Cave suggest they may have had spiritual or religious concepts. These aren't the behaviours of simplistic beings concerned only with immediate survival needs. They suggest Neanderthals had rich inner lives, that they thought about abstract concepts, formed deep emotional attachments, and perhaps contemplated questions about existence and meaning in ways not dissimilar to our own. Recent genetic research has provided intriguing hints about Neanderthal psychology. Studies of Neanderthal DNA suggest they may have had a greater tendency toward depression and mood disorders compared to modern humans, potentially an adaptation to the long, dark winters of Northern Europe, where conserving energy through reduced activity during the harshest season might have been advantageous. Other genetic evidence suggests potential differences in social behaviour. Neanderthals appear to have had smaller, more tightly knit social groups than early modern humans. This social structure may have been an adaptation to the environments they inhabited, where resources were often sparse and widely scattered, making large group living impractical. These smaller, more intimate social groups might have fostered intense bonds between individuals, but potentially limited the scale of cooperation and information sharing compared to the larger networks maintained by early modern humans. This difference in social structure, not any deficit in individual cognitive capacity, may help explain some of the differences in cultural development between the two species. The picture that emerges from all this evidence is of Neanderthals as sophisticated beings with complex social lives, rich cultural traditions, and cognitive capabilities not fundamentally different from our own. They weren't lesser versions of us, but a different expression of humanity, adapted to different environments and circumstances, but no less intelligent or capable. Their physical adaptations, the powerful bodies, the cold-adapted physiology, the enhanced visual systems, were matched by equally impressive cultural adaptations. They developed technologies perfectly suited to their needs, accumulated knowledge about their environments that allowed them to exploit resources efficiently, and created social structures that supported their lifestyle in some of the most challenging environments on Earth. For hundreds of thousands of years, far longer than our species has existed, they thrived across Europe and parts of Asia. They weathered multiple glacial cycles, survived dramatic climate shifts, and developed cultural traditions that were passed down through countless generations. Their success wasn't accidental or temporary. It was the result of sophisticated adaptations, both biological and cultural. So why did they disappear while our ancestors thrived? As discussed earlier, the answer likely involves multiple factors: climate change, competition with expanding modern human populations, potentially disease, and demographic challenges related to their small, isolated population structure. But their disappearance doesn't invalidate their achievements or diminish their significance in the story of human evolution. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who dominated Ice Age Europe for hundreds of millennia, and whose genetic legacy lives on in many of us today. Perhaps the most important lesson from our growing understanding of Neanderthals is that there are many ways to be human, many paths that our evolution might have taken. The Neanderthals represent an alternative expression of humanity, different from us in important ways, but equally valid, equally sophisticated, and equally worthy of our respect and admiration. They weren't just freaks of nature in terms of their physical strength. They were extraordinary beings in every sense, physically, cognitively, technologically, and culturally. Their story isn't a sidebar in human evolution, but a parallel narrative of a different, but equally valid way of being human. And as we'll explore in the next part of our journey, the relationship between Neanderthals and our direct ancestors, the early modern humans who expanded out of Africa around 60,000 years ago, is far more complex and intriguing than the simple tale of replacement that dominated scientific thinking for decades. The evidence suggests not just competition, but interaction, admixture, and potentially cultural exchange, a fascinating chapter in the human story that continues to unfold as new discoveries are made. What's clear is that Neanderthals weren't just strong, they were sophisticated. They weren't just survivors, they were innovators, and they weren't failed humans. They were successful, intelligent beings who thrived in environments we can barely survive in today. Their story deserves to be told not as a footnote in human evolution, but as a remarkable chapter in its own right, the tale of another kind of human who walked the earth alongside our ancestors and whose legacy lives on in our genes and in our growing appreciation for the diversity of human experience. We've journeyed deep into the world of Neanderthals, exploring their extraordinary physical capabilities, their sophisticated minds, and the complex cultural adaptations that allowed them to thrive in the harshest environments of Ice Age Europe. But their story becomes even more fascinating when we examine their interactions with our direct ancestors, the anatomically modern humans who began migrating out of Africa around 70,000 years ago and eventually reached Europe around 45,000 years ago. The traditional narrative of this encounter was simple and dramatic. Superior modern humans, armed with more advanced technology and greater intelligence, rapidly replaced the primitive Neanderthals through competition for resources or even direct conflict. It was a compelling story that positioned our ancestors as the inevitable victors in an evolutionary contest, but like so many simple narratives about complex historical processes, it was fundamentally wrong. The real story, revealed through decades of archaeological research and recently transformed by genetic discoveries, is far more nuanced and intriguing. It isn't a tale of superior beings replacing inferior ones, but of two highly adapted human species, each with their own strengths and specialized adaptations, encountering one another after hundreds of thousands of years of separate evolution. To understand this encounter, we need to first understand who these early modern humans were, our direct ancestors who had evolved in Africa while Neanderthals were adapting to the harsh conditions of Ice Age Europe. Anatomically modern humans, Homo sapiens, emerged in Africa around 300,000 years ago, while Neanderthals were developing stockier, more powerful bodies adapted to cold environments. Our ancestors were evolving in the varied environments of Africa, from savannas to forests, from highlands to coastal regions. This diverse ecological background may help explain some of the differences between the two species. Modern humans developed more gracile bodies, taller, lighter, with longer limbs and less muscle mass than Neanderthals. These proportions were better suited to heat dissipation in warm climates and may have provided greater endurance at the expense of raw power. Where Neanderthals were sprint specialists, modern humans were marathon runners, capable of persistence hunting that involved tracking prey over long distances until the animals collapsed from exhaustion. Their technology reflected these differences, where Neanderthals excelled at creating heavy thrusting spears for close-quarters hunting. Early modern humans developed projectile weapons, lightweight spears that could be thrown from a distance, and eventually atlatls, spear throwers, that extended their throwing range even further. These technologies minimized the risk of injury from dangerous prey and matched the more gracile, endurance-oriented physique of modern humans. By around 70,000 years ago, groups of modern humans began expanding beyond Africa, moving first into the Middle East and then gradually spreading across Asia, reaching Australia by about 65,000 years ago. Their expansion wasn't a single coordinated migration, but a series of movements by different groups over thousands of years. When they reached Europe around 45,000 years ago, they encountered landscapes and conditions very different from their African homeland. Europe was in the grip of the last ice age, with environments ranging from cold steppes in the north to Mediterranean woodlands in the south. And inhabiting these challenging landscapes were the Neanderthals, humans whose bodies and cultures had been adapting to these conditions for hundreds of thousands of years. What happened when these two human species met? For decades, the archaeological record seemed to tell a simple story. Modern humans appeared in Europe, and within a few thousand years, Neanderthals disappeared. This apparent correlation led many researchers to conclude that modern humans had simply outcompeted Neanderthals, perhaps due to superior technology, greater intelligence, or more efficient subsistence strategies. But recent discoveries have revealed a much more complex picture. The first bombshell came in 2010 when genetic researchers announced they had sequenced the Neanderthal genome and made a startling discovery. Most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. This was clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. Subsequent genetic studies have refined our understanding of this interbreeding. It appears to have occurred multiple times between 45 and 55,000 years ago, primarily in the Middle East, but potentially in Europe as well. The pattern of Neanderthal DNA in modern human genomes suggests the interbreeding wasn't just rare, isolated events, but occurred with sufficient frequency to leave a lasting genetic legacy. This discovery fundamentally changed our understanding of the relationship between modern humans and Neanderthals. It wasn't a simple case of one species replacing another, but a complex process involving both competition and intermixing. Neanderthals didn't simply go extinct in a very real sense. Aspects of them live on in many of us today. The genetic evidence also revealed something fascinating about the nature of this interbreeding. Certain types of Neanderthal DNA were retained in the modern human genome, while others were selectively removed over generations. This suggests some Neanderthal gene variants provided advantages to modern humans adapting to Eurasian environments, while others were neutral or detrimental. Among the Neanderthal gene variants that appear to have been beneficial are those related to skin and hair characteristics that may have helped modern humans adapt to northern latitudes with less sunlight, genes involved in fat metabolism that could have aided survival in colder climates, and immune system genes that may have provided resistance to pathogens prevalent in Eurasia but not in Africa. On the other hand, there's a notable scarcity of Neanderthal DNA on the X chromosome and in genes related to male fertility, suggesting male hybrids may have had reduced fertility, a common pattern in hybridization between closely related species. There also appears to have been selection against Neanderthal variants of certain genes involved in brain development, though the implications of this remain unclear. The interbreeding between Neanderthals and modern humans wasn't just a biological process, it must have involved social interactions as well. We can only speculate about the nature of these encounters, but they clearly involved sufficient social integration for mating and reproduction to occur. Did Neanderthal individuals join modern human groups? Did modern humans join Neanderthal bands? Were there mixed communities where both species lived together? The archaeological record provides tantalizing hints but few definitive answers. What's clear is that the boundary between the two species was permeable enough for significant genetic exchange to occur. This genetic evidence has forced a fundamental reconsideration of the relationship between modern humans and Neanderthals. Rather than a simple replacement, it now appears to have been a complex process involving both competition and assimilation. As modern human populations expanded and Neanderthal populations declined, likely due to a combination of climate change, competition, and possibly disease, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The archaeological evidence for interaction between the two species is more ambiguous but nonetheless intriguing. In several regions of Europe, particularly France and northern Spain, archaeologists have identified cultural traditions that appear to blend elements of Neanderthal and modern human technologies. The most famous of these is the Chapelle-aux-Saints industry, a tool-making tradition found in central France and northern Spain dating to around 40 to 45,000 years ago. Chapelle-aux-Saints tools combine elements typical of Neanderthal Mousterian technology with features more characteristic of the early modern human Aurignacian industry, particularly the production of blade tools and bone implements. For years, archaeologists debated whether the Chapelle-aux-Saints represented Neanderthals adopting aspects of modern human technology through cultural contact, or modern humans incorporating elements of Neanderthal technology into their own traditions. The discovery of Neanderthal remains in clear association with Chapelle-aux-Saints tools at the site of Arcy-sur-Cure in France seemed to settle the question in favour of the former interpretation. These were Neanderthals adopting aspects of modern human technology. But recent redating of some key sites has complicated this picture. It now appears that in some regions the Chapelle-aux-Saints may have developed before modern humans arrived in the area, suggesting independent innovation by Neanderthals rather than borrowing from newcomers. In other regions, the chronological overlap between the two species is clearer, making cultural exchange more plausible. Whatever the exact mechanisms, it's clear that the relationship between Neanderthals and modern humans wasn't simply one of competition and replacement. There was interaction, genetic exchange, and potentially cultural transmission in both directions. The old narrative of superior modern humans replacing primitive Neanderthals has given way to a much more nuanced understanding of a complex encounter between two highly adapted human species. This revised understanding of the Neanderthal-modern human relationship raises fascinating questions about the nature of cognitive and cultural differences between the two species. If Neanderthals were capable of interbreeding with modern humans, adopting or independently inventing similar technologies and potentially exchanging cultural knowledge, how different were they really? The genetic evidence suggests the two species diverged from a common ancestor between 500 and 700,000 years ago. This is a significant period of separate evolution, enough time for substantial biological differences to develop, as evidenced by the distinct physical characteristics of Neanderthals and modern humans. But it's important to remember that for most of this time, both species were developing as intelligent cultural beings within the genus Homo. The differences between Neanderthals and modern humans are better understood not as differences in fundamental cognitive capacity, but as differences in specialized adaptations to distinct environments and lifestyles. Neanderthals weren't less intelligent than modern humans. They were differently intelligent, their cognitive abilities shaped by the specific challenges of life as Ice Age hunters in Europe. This perspective helps explain both the impressive achievements of Neanderthal culture, their sophisticated technologies, their successful adaptation to harsh environments, their apparent capacity for symbolic expression, and the differences between their cultural trajectory and that of modern humans. Modern humans, evolving in the more diverse environments of Africa, may have developed greater cultural flexibility, an ability to rapidly adapt their behaviors and technologies to new circumstances. This flexibility would have been advantageous as they expanded into new environments across Asia, Australia, and eventually Europe. It's not that they were smarter than Neanderthals, but that their cognitive adaptations were suited to a more mobile, exploratory lifestyle. Neanderthals, in contrast, appear to have developed deep, specialized knowledge adapted to specific European environments. Their technologies and subsistence strategies were highly effective for the conditions they faced, but may have been less adaptable to rapid environmental change. Again, this doesn't reflect lesser intelligence, but a different adaptive strategy, depth of knowledge rather than breadth. These different cognitive adaptations may help explain why modern humans were ultimately more successful in the face of the rapid climate fluctuations that characterized the period between 40 and 30,000 years ago. As conditions changed, modern humans may have been able to adjust their behaviors and technologies more quickly, while Neanderthals' specialized adaptations became less viable. The social structures of the two species likely differed as well, with important implications for their interaction. Genetic evidence suggests Neanderthals lived in relatively small, isolated groups with limited interaction between communities. This social structure would have been well suited to environments where resources were scattered and populations needed to be widely distributed, but it may have limited the exchange of innovations and made them vulnerable to localized extinction events. Modern humans, in contrast, appear to have maintained larger social networks with more regular interaction between groups. This social structure would have facilitated the spread of innovations, provided buffers against local resource shortages, and potentially given them a demographic advantage when the two species came into competition. These differences in social structure may have played a crucial role in the ultimate fate of the Neanderthals. As climate fluctuations stressed local ecosystems and modern humans expanded into Neanderthal territories, the more connected modern human populations may have been better able to withstand these pressures than the relatively isolated Neanderthal bands. It's important to note that none of these differences imply modern humans were inherently superior to Neanderthals. Both species had developed highly successful adaptations to their respective environments. Neanderthals thrived in Ice Age Europe for hundreds of thousands of years, far longer than our species has existed. Their eventual disappearance wasn't due to any intrinsic deficiency, but to a complex interplay of factors including climate change, competition, and demographic challenges. The timing of Neanderthal disappearance varied across Europe, with the latest convincing evidence coming from sites in Gibraltar dated to around 40,000 years ago, and possibly as late as 37,000 years ago in isolated pockets of Iberia. This gradual contraction of their range, rather than a sudden continent-wide extinction, is consistent with a complex process involving multiple factors rather than a single decisive cause. Climate change clearly played a role. The period between 40 and 30,000 years ago saw dramatic climate fluctuations, including several severe cold episodes known as Heinrich events. These sudden cooling periods would have stressed the ecosystems Neanderthals relied on, potentially reducing the populations of their preferred prey species and making their high-calorie, meat-heavy diet more difficult to sustain. Modern humans, with their slightly different technological toolkit and potentially more flexible subsistence strategies, may have been better equipped to weather these changes. Evidence suggests early modern humans exploited a broader range of food resources, including small game and aquatic foods that appear less frequently in Neanderthal sites. But it wasn't just about technology or subsistence. Demographic factors likely played a crucial role. Genetic studies of Neanderthal remains suggest they maintained relatively small, isolated populations with limited genetic diversity. This would have made them vulnerable to inbreeding, depression, reduced fitness due to the accumulation of harmful genetic variants. A fascinating study published in 2019 used computer modelling to examine whether demographic factors alone could have led to Neanderthal extinction. The researchers found that even without climate change or competition, the small population size of Neanderthals and their vulnerability to inbreeding depression could have led to their disappearance. Add in the stresses of climate fluctuations and competition with expanding modern human populations, and their fate becomes more understandable. The most likely scenario is that all these factors, climate change, competition, demographic challenges, and possibly disease, interacted in complex ways that varied across different regions of Europe. In some areas, climate change may have been the primary driver of Neanderthal decline. In others, direct competition with modern humans may have played a larger role. And throughout the process, the small, isolated nature of Neanderthal populations would have made them increasingly vulnerable to local extinction events. As Neanderthal populations dwindled, the remaining individuals may have increasingly joined modern human groups, a process suggested by the genetic evidence for interbreeding. This wouldn't have been a simple one-way assimilation, however. The modern humans who encountered Neanderthals would have had much to learn from these highly adapted residents of Ice Age Europe. Neanderthals had accumulated generations of knowledge about European environments, which plants were edible or medicinal, how to track and hunt the local prey species, where to find essential resources like water and stone for tools. Modern humans, as newcomers to these landscapes, would have benefited enormously from this local knowledge. It's intriguing to consider what other aspects of Neanderthal culture might have been transmitted to modern humans during this period of contact. Did modern humans learn hunting techniques from Neanderthals? Did they adopt aspects of Neanderthal technology like the production of birch bark tar adhesives? Did they incorporate Neanderthal medicinal practices or spiritual beliefs into their own cultural traditions? The archaeological record provides few clear answers, but the possibility of such cultural exchange adds another fascinating dimension to the story of the encounter between these two human species. It wasn't simply modern humans replacing Neanderthals, but a complex process of interaction that potentially involved both genetic and cultural exchange. This revised understanding of the Neanderthal-modern human relationship has profound implications for how we think about human evolution and diversity. It challenges the linear, progressive view that has dominated much of paleoanthropology, the idea that evolution produced a series of increasingly advanced human species culminating in Homo sapiens as the pinnacle of the process. Instead, it suggests a more complex branching pattern where different human species evolved in parallel, each developing specialized adaptations to particular environments and lifestyles. Neanderthals weren't a stepping stone on the path to modern humans, but a distinct branch of humanity with their own unique evolutionary trajectory. This perspective aligns with what we now know about other members of the human family tree. The discovery of Homo floresiensis, the so-called hobbits of Indonesia, and Homo luzonensis in the Philippines reveals that multiple human species existed alongside our own until relatively recently. And the identification of the Denisovans, another distinct human species that interbred with both Neanderthals and modern humans, further complicates the picture. Far from being the linear march of progress depicted in those familiar textbook illustrations, human evolution was a complex bush with multiple branches developing in parallel, sometimes interacting and hybridizing, sometimes competing, but each representing a valid and successful adaptation to particular circumstances. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who thrived in challenging environments for hundreds of thousands of years through a combination of biological and cultural adaptations. Their physical power, those extraordinarily strong bodies that have been the focus of much of our exploration, was just one aspect of a complex and sophisticated adaptation to life in Ice Age Europe. Their legacy lives on not just in the DNA many of us carry, but in our growing appreciation for the diversity of human experience and the many ways to be human. The story of the Neanderthals reminds us that our species' current dominance of the planet isn't the inevitable result of inherent superiority, but the outcome of a complex historical process involving both chance and adaptation. And it raises profound questions about human identity and uniqueness. If another human species existed alongside our own until relatively recently, a species with comparable cognitive capabilities, complex cultural traditions, and the ability to interbreed with us, what does that say about our place in nature? What might our world be like if Neanderthals had survived to the present day? These questions take on added significance as we consider the possibility of encountering non-human intelligence in the future, whether through artificial intelligence or potential contact with extraterrestrial beings. Our experience with Neanderthals suggests that intelligence and complexity can take different forms, and that our human-centric perspective may limit our ability to recognize and appreciate these differences. The Neanderthals, with their powerful bodies, sophisticated minds, and complex cultural adaptations, represent both a mirror and a window. A mirror reflecting aspects of ourselves that we share with these ancient relatives, and a window into alternative possibilities for being human. Their story isn't just about who they were, but about who we are and who we might have been under different circumstances. As we continue to uncover new evidence about these remarkable beings, our understanding of them grows ever richer and more nuanced. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more respectful appreciation of Neanderthals as sophisticated, intelligent beings with rich cultural traditions and complex social lives. They weren't just freaks of nature in terms of their physical strength, they were extraordinary beings in every sense, whose story continues to fascinate and inform our understanding of what it means to be human. And as we'll explore in the final part of our journey, the legacy of the Neanderthals extends far beyond their physical disappearance, influencing not just our biology through the genes we inherited from them, but our understanding of ourselves and our place in the natural world. Throughout our exploration of Neanderthals, we've discovered that these ancient humans were truly extraordinary beings, not just in terms of their remarkable physical strength, but in their cognitive abilities, technological innovations, and social complexity. Far from being the primitive cavemen of popular imagination, they were sophisticated humans perfectly adapted to the harsh environments of Ice Age Europe. But perhaps the most surprising aspect of the Neanderthal story is how their legacy continues to influence us today, not just through the genes many of us carry, but through what their existence reveals about human nature and the course of our evolution. In this final chapter, we'll explore the lasting impact of Neanderthals on our biology, our self-understanding, and our vision of humanity's past and future. Let's begin with their most direct legacy, the Neanderthal DNA that lives on in many modern humans. When researchers first sequenced the Neanderthal genome in 2010, they made the startling discovery that most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. This was conclusive evidence that our ancestors didn't simply replace Neanderthals, they interbred with them, and we carry the genetic legacy of those encounters. Subsequent research has revealed the complex pattern of this genetic inheritance. Not all Neanderthal genes were equally likely to be retained in the modern human genome. Some appear to have been advantageous and were favoured by natural selection, while others were gradually eliminated from our gene pool. Among the beneficial Neanderthal genes that many modern humans still carry are variants related to skin and hair characteristics that may have helped our ancestors adapt to northern latitudes with less sunlight. Neanderthals had been living in these environments for hundreds of thousands of years before modern humans arrived, and they had developed genetic adaptations to cope with the reduced UV exposure, adaptations that proved beneficial to modern humans moving into similar environments. Other retained Neanderthal genes are involved in fat metabolism and may have helped modern humans adapt to colder climates where efficient energy storage and utilization were crucial for survival. Still others affect immune function, potentially providing resistance to pathogens prevalent in Eurasia but not in Africa, giving modern humans a survival advantage as they expanded into new territories. The distribution of Neanderthal DNA in modern populations tells an intriguing story about human migrations and interactions. People of East Asian descent typically carry slightly more Neanderthal DNA than Europeans, suggesting multiple episodes of interbreeding as modern humans spread across Eurasia. Indigenous populations in sub-Saharan Africa, whose ancestors didn't migrate through Eurasia, have little to no Neanderthal DNA, a pattern that perfectly matches what we would expect if interbreeding occurred primarily after modern humans left Africa. Some Neanderthal gene variants appear to influence traits that go far beyond simple physical adaptations. Certain Neanderthal genes have been linked to aspects of neurological function, immune response, and even mood regulation. One fascinating example is a Neanderthal variant that affects the risk of depression, potentially representing an adaptation to the long, dark winters of northern Europe, where reducing activity during the harshest season might have been advantageous. Other Neanderthal variants have been associated with conditions like Crohn's disease, type 2 diabetes, and even susceptibility to certain viral infections, including, intriguingly, severe COVID-19. The relationship between these genetic variants and disease risk is complex. What might have been adaptive in the Paleolithic environment may have different effects in our modern world, with its dramatically different diet, lifestyle, and disease exposure. The pattern of Neanderthal genes that weren't retained in the modern human genome is equally revealing. There's a notable scarcity of Neanderthal DNA on the X chromosome and in genes related to male fertility, suggesting male hybrids may have had reduced fertility, a common pattern in hybridization between closely related species. This reduced male fertility may help explain why the overall percentage of Neanderthal DNA in modern humans remains relatively low despite evidence for multiple interbreeding events. There also appears to have been selection against Neanderthal variants of certain genes involved in brain development. The implications of this pattern remain unclear. It could reflect incompatibilities between Neanderthal and modern human neural development, or it might simply be the result of random evolutionary processes unrelated to cognitive function. What's clear is that we are, in a very real sense, part Neanderthal. Their genetic legacy lives on in most non-African populations, influencing various aspects of our biology in ways we're only beginning to understand. This biological connection to these ancient relatives forces us to reconsider the traditional narrative of human origins and the relationship between different human species. But the legacy of Neanderthals extends far beyond just the genes they contributed to our DNA. Their very existence and our growing understanding of their sophisticated nature has fundamentally changed how we think about human evolution and diversity. For much of the 20th century, human evolution was portrayed as a linear progression from primitive, ape-like ancestors to increasingly advanced forms, culminating in Homo sapiens as the pinnacle of the process. Neanderthals were positioned as a side branch, an evolutionary dead end that couldn't compete with our supposedly superior species. This linear, progressive view of human evolution reflected the cultural biases of the time more than the actual evidence. It positioned modern humans, particularly Europeans who were doing most of the research, as the inevitable winners of an evolutionary contest, justifying their global dominance as the natural outcome of superior capabilities. The revised understanding of Neanderthals that has emerged in recent decades completely undermines this self-serving narrative. Neanderthals weren't primitive or less evolved. They were highly adapted humans whose physical and cultural characteristics reflected hundreds of thousands of years of successful evolution in specific environments. They weren't an evolutionary dead end, but a remarkably successful branch of humanity that thrived for far longer than our species has existed. This perspective aligns with what we now know about human evolution more broadly. Rather than a linear march of progress, the evidence reveals a complex bush with multiple branches developing in parallel, each representing successful adaptations to particular circumstances. Modern humans aren't the culmination of this process, but simply the last surviving twig on a once much more diverse human family tree. This revised understanding has profound implications for how we think about human identity and uniqueness. If another human species existed alongside our own until relatively recently, a species with comparable cognitive capabilities, complex cultural traditions, and the ability to interbreed with us, what does that say about our place in nature? What makes us human may not be unique to Homo sapiens, but shared across multiple species within the genus Homo. The Neanderthal story also challenges our assumptions about progress and adaptation. Their disappearance wasn't because they were somehow less advanced or capable than modern humans. It was the result of a complex interplay of factors including climate change, demographic challenges, and the specific historical circumstances of their encounter with our ancestors. Had circumstances been different, had the climate been more stable, had modern humans arrived in Europe at a different time, had Neanderthal populations been larger or more connected, the outcome might have been different. We might today live in a world where Neanderthals still existed as a distinct population, or where hybridization had proceeded further, creating a more even genetic blend of the two species. These counterfactual scenarios aren't just idle speculation, they highlight the contingent nature of evolutionary history. Our species' current dominance of the planet isn't the inevitable result of inherent superiority, but the outcome of a complex historical process involving both chance and adaptation. The Neanderthals remind us that evolution doesn't have a predetermined direction or goal. It produces diversity, not progress towards some ideal form. This revised understanding of human evolution has practical implications for how we approach conservation and biodiversity today. If human diversity once included multiple species with different adaptations and capabilities, the loss of that diversity represents a significant narrowing of evolutionary possibilities. Our species now stands alone as the only surviving member of our genus, having lost the alternative perspectives and adaptations that other human species represented. This diminished diversity makes us more vulnerable as a species. If all humans share the same fundamental adaptations and vulnerabilities, we're more susceptible to catastrophic threats that exploit those shared characteristics. The existence of multiple human species, each with different strengths and adaptations, would provide greater resilience against such threats, whether disease, climate change, or other challenges. The Neanderthal story offers a sobering reminder of how quickly a successful, well-established species can disappear when circumstances change. For hundreds of thousands of years, Neanderthals were the dominant human species in Europe. Their robust bodies and sophisticated cultures perfectly adapted to Ice Age conditions. Yet within a few thousand years of modern humans arriving in their territories, an eye blink in evolutionary time, they had vanished as a distinct population. Their fate raises uncomfortable questions about our own species' future. Like the Neanderthals, we've developed highly specialized adaptations to particular environmental and social conditions. Our technology, our social structures, and our ways of life depend on a relatively stable climate and predictable resource availability. As we face accelerating climate change and environmental degradation, the rapid disappearance of the Neanderthals serves as a warning about the potential fragility of even long-established and successful species. But the Neanderthal story isn't just a cautionary tale, it's also a source of hope and expanded possibilities. The evidence for interbreeding between Neanderthals and modern humans challenges simplistic notions of species boundaries and suggests a more fluid, interconnected view of life and evolution. It reminds us that differences don't necessarily preclude meaningful interaction, genetic exchange, and potentially cultural sharing. This perspective has relevance for contemporary discussions about human diversity and identity. If our ancestors could recognize Neanderthals with their distinctive appearance and separate evolutionary history as potential mates and social partners, perhaps we can more readily acknowledge the fundamental commonality that underlies the relatively minor variations between modern human populations. The Neanderthal story also expands our conception of what it means to be human. For centuries, Western philosophy and religion positioned humans as categorically distinct from other animals, unique in our cognitive abilities, our moral awareness, our capacity for culture and technological innovation. The discovery that Neanderthals shared many of these supposedly unique human traits suggests a more continuous view of intelligence and complexity across species. This continuity extends in both directions, not just to other human species like Neanderthals, but potentially to non-human animals as well. If Neanderthals, with brains organized somewhat differently than our own, could develop complex cultures, sophisticated technologies, and possibly symbolic expression, perhaps we should be more open to recognizing similar capabilities in other intelligent species, like cetaceans, elephants, or great apes, each with their own unique neurological organization adapted to their specific environmental challenges. The recognition that intelligence and complexity can take different forms has implications for how we might approach non-human intelligence in the future, whether through artificial intelligence or potential contact with extraterrestrial beings. Our experience with Neanderthals suggests that we should be cautious about imposing our specific cognitive patterns as the only valid form of intelligence and be open to recognizing and valuing different expressions of complex thought and behavior. As we continue to uncover new evidence about Neanderthals through archaeological discoveries and advanced analytical techniques, our understanding of these ancient relatives grows ever richer and more nuanced. Each new finding, whether a sophisticated tool, evidence of symbolic behavior, or insights from ancient DNA, adds another piece to the puzzle of who they were and how they lived. Recent technological advances have dramatically accelerated this process. Improvements in DNA extraction and analysis techniques have allowed researchers to recover genetic material from increasingly ancient specimens, including some more than 100,000 years old. These advances have revealed not just the Neanderthal genome, but evidence of other extinct human species like the Denisovans, known almost exclusively from their DNA rather than physical remains. New dating techniques have provided more precise chronologies for Neanderthal sites, allowing researchers to correlate archaeological evidence with specific climate events and potential interactions with modern humans. Advanced imaging technologies have revealed details of Neanderthal anatomy that weren't visible using traditional methods, from the structure of their inner ears to the development patterns of their teeth and bones. Perhaps most excitingly, researchers are beginning to extract and analyze proteins and other biomolecules from ancient specimens, potentially revealing aspects of Neanderthal biology that aren't recorded in their DNA. Analysis of dental calculus, the hardened plaque on teeth, has provided insights into Neanderthal diet, health, and potential medicinal practices that weren't accessible through traditional archaeological methods. These technological advances promise to continue expanding our understanding of Neanderthals in the coming years. We may soon be able to reconstruct aspects of their sensory experiences, how they perceived their world through sight, smell, and hearing. We might gain insights into currently invisible aspects of their biology, from their gut microbiomes to their hormonal patterns. and we may be able to track changes in their genetic diversity and population structure over time, revealing how they responded to climate fluctuations and other challenges throughout their long history. As our knowledge of Neanderthals grows, so too does our appreciation for who they were, not primitive precursors to modern humans, but sophisticated beings with their own unique adaptations and capabilities. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more respectful understanding of Neanderthals as complex, intelligent humans who thrived in challenging environments through a combination of biological and cultural adaptations. This revised understanding is gradually making its way into popular culture as well. Recent depictions of Neanderthals in documentaries, museum exhibits, and even fiction have moved away from the stereotypical caveman image toward more accurate and respectful portrayals that emphasize their humanity and sophistication. These cultural representations matter. They shape public perception and influence how we think about human diversity and evolution. The Neanderthals have also become central to ongoing scientific and philosophical discussions about human origins, species boundaries, and the nature of intelligence. Their story challenges us to reconsider deeply held assumptions about progress, superiority, and what it means to be human. They remind us that our current status as the only surviving human species is a recent and perhaps temporary situation. For most of human evolutionary history, multiple human species coexisted on Earth. This perspective encourages a certain humility about our place in nature. Modern humans aren't the inevitable culmination of evolutionary progress, but simply the last surviving branch of a once more diverse human family tree. Our global dominance isn't the result of inherent superiority, but a complex historical process involving both adaptation and chance. And the sophisticated nature of Neanderthals reminds us that many of the capabilities we consider uniquely human, from technological innovation to symbolic expression, have deep evolutionary roots and may be shared across multiple species. At the same time, the Neanderthal story highlights the remarkable adaptability of the genus Homo, our broader human family. Both Neanderthals and modern humans developed sophisticated cultural and technological systems that allowed them to thrive in challenging environments. From the frigid landscapes of Ice Age Europe to the varied habitats of Africa and beyond. This adaptability, driven by the combination of biological evolution and cultural innovation, has been the hallmark of our lineage for millions of years. The fate of the Neanderthals, their eventual disappearance as a distinct population after hundreds of thousands of years of successful adaptation, serves as both a cautionary tale and a reminder of the dynamic nature of evolution. No species, no matter how well established or successful, is guaranteed permanent existence. Changing environments, competition, demographic challenges, and simple chance can lead to extinction even for highly adapted and intelligent beings. For our own species, now facing accelerating climate change, environmental degradation, and other unprecedented challenges, the Neanderthal story offers both warning and inspiration. It warns us about the potential fragility of even long-established species when circumstances change rapidly. But it also reminds us of the remarkable adaptability of humans, our capacity to develop new technologies, social structures, and ways of life in response to changing conditions. The key question is whether we can draw on this adaptability consciously and deliberately, using our understanding of the past to make wise choices about our future. Can we learn from the Neanderthals, both their successes and their ultimate disappearance, as we navigate the challenges of the Anthropocene? One lesson from the Neanderthal story is the importance of diversity, both biological and cultural. The evidence suggests Neanderthals maintained relatively small, isolated populations with limited genetic diversity, potentially making them more vulnerable to extinction events. Modern humans, in contrast, appear to have maintained larger, more connected population networks with more genetic mixing between groups, providing greater resilience in the face of environmental challenges. Similarly, the diversity of human cultures and knowledge systems today represents a crucial resource for addressing complex challenges. Different cultural traditions offer varied perspectives, knowledge bases, and adaptive strategies that collectively expand our species' capacity to respond to changing conditions. Just as the interbreeding between Neanderthals and modern humans may have enhanced our ancestors' adaptability by incorporating beneficial Neanderthal gene variants, the exchange and integration of diverse cultural knowledge can enhance our collective capacity to address contemporary challenges. Another lesson lies in the Neanderthals' remarkable sustainability. For hundreds of thousands of years, they maintained stable populations in balance with their environments, never reaching the kind of numbers or resource consumption that would trigger ecosystem collapse. Their technologies, while sophisticated, were based on renewable materials and processes that left minimal permanent impact on the landscape. This stands in stark contrast to our current situation where exponential population growth and resource consumption are pushing planetary systems toward potential breaking points. The Neanderthals remind us that it's possible to develop sophisticated cultures and technologies without the kind of environmental devastation that characterizes the industrial and post-industrial era. Their example challenges us to reimagine progress in ways that prioritize sustainability and balance with natural systems. Perhaps the most profound lesson from the Neanderthal story is the reminder that we are part of a much larger and more complex human narrative than we often acknowledge. Our species' current global dominance represents just the latest chapter in a long story of human evolution and adaptation that spans millions of years and includes multiple species with different capabilities and lifeways. The Neanderthals, with their powerful bodies, sophisticated minds, and complex cultural adaptations, represent both a mirror and a window. A mirror reflecting aspects of ourselves that we share with these ancient relatives, and a window into alternative possibilities for being human. Their story isn't just about who they were, but about who we are and who we might have been under different circumstances. As we move forward into an uncertain future, the Neanderthals remind us of both the remarkable adaptability of the human lineage and the potential fragility of even long-established species. They challenge us to reconsider what it means to be human and to recognize the value of diversity, both biological and cultural, in enhancing our collective resilience. Their legacy lives on not just in the DNA many of us carry, but in our expanding conception of humanity and our place in nature. They weren't simply freaks of nature with extraordinary physical strength. They were sophisticated, intelligent beings who represent an alternative expression of humanity. Their story enriches our understanding of what it means to be human and expands our vision of what might be possible for our species in the future. The next time you look in the mirror, remember that for many people, a small but significant portion of what you see reflects the genetic legacy of these remarkable ancient humans. The Neanderthals aren't just a fascinating chapter in our evolutionary past. They're part of who we are today, their genes and their story woven into the fabric of our biology and our self-understanding. And as we face the complex challenges of the 21st century, from climate change to pandemics, from technological disruption to social transformation, the Neanderthals offer a valuable perspective that combines caution and hope. They caution us about the potential fragility of even successful species when circumstances change rapidly, but they also remind us of the remarkable adaptability of the human lineage and our capacity to thrive in challenging environments through a combination of biological and cultural innovation. Their story continues to unfold as new discoveries reveal more about who they were and how they lived. Each finding adds another piece to the puzzle of our shared human past and expands our understanding of what it means to be human. The Neanderthals, once dismissed as primitive brutes, have emerged as sophisticated, complex beings whose legacy enriches our appreciation of human diversity and possibility. They truly were freaks of nature, not in the dismissive sense that term is sometimes used, but in the sense of being extraordinary, remarkable beings whose physical and cognitive adaptations allowed them to thrive in some of the most challenging environments on Earth. Their story deserves to be told not as a footnote in human evolution, but as a remarkable chapter in its own right, the tale of another kind of human who walked the earth alongside our ancestors and whose legacy lives on in our genes and in our growing appreciation for the diversity of human experience.